Okay, so this video is still on 9-4. We just did that huge number 1 homework problem. Yeah, okay. And now we're gonna learn more about the derivative. Earlier I said that the derivative is the exact same thing as slope, sort of, kind of. Okay, if we remember back to college algebra or business math 1, there were 2 equations that we used to find the slope. We used this y2 minus y1 over x2 minus x1. That was the slope of a line when we look at 2 points on that line. And then in college algebra or business math 1, we also use something called the average rate of change, which means if you're looking at a curve, like this blue curve, this blue curve, here's the blue curve. Average rate of change means the slope of the line that crosses through 2 points of that curve. So here's 1 point of that curve, here's another point of that curve, and the line that is created that goes through that curve, we can find the slope of that line. And once we do, it's called the average rate of change. So we already have 2 slope formulas from back in the day, y2 minus y1 and this average rate of change. Now, this average rate of change, f of b minus f of a over b minus a, we still use that, but instead of average rate of change, it's called the slope of the secant line. So we still have a curve. See, here's the curve, here's the curve. But then a secant line is one that passes through 2 points on your curve. Secant line is a line that passes through 2 points of your curve. And it can be any 2 points of your curve. So if I wanted to know the rate of change of this curve, like how fast this curve changes, the only thing we know so far is the average rate of change from college algebra between 2 points. Okay, so another way to write that average rate of change formula is right here. F of x minus f of a all over x minus a. And it even says average rate of change. So that's the same thing that we did in college algebra or business math 1. It just looks a little different. If you notice, instead of the b's, there's now x's. But other than that, same formula. We're subtracting something, divided by, more subtracting. Okay, another way to change up this formula that we might see is this right here. F of a plus h minus f of a, blah, blah, blah. Or its counterpart on the right side, f of a plus h. So all of this is for something called the secant line. Secant line means it passes through 2 dots on your curve. Okay, then we have something called the tangent line. Tangent line only passes through 1 dot of your curve. So, for example, if we look at this picture on the bottom, there's 1 dot on the curve, and the tangent line passes through just that 1 dot. So tangent lines only pass through 1 point. And to find the slope of that tangent line, we use that same average rate of change, but we change it a little bit. Instead of the A's and the H's, or instead of the A's, my bad, I meant to say we can use the A's or we can use the X's, like either one of these formulas did. The only thing extra is there's a limit on it. So, and that limit, you plug in a 0 for H. So, if we look back to the very first number 1 problem that we did from our homework, This sucker right here with the f parentheses 2 minus f parentheses 1, that is technically the average rate of change from college algebra and business math. Average rate of change, okay? Then on part 2, or this part B of number 1, we did this f of 1 plus h minus f of 1. Let's see for the f's. That's this sucker. Because see, it has the h's, and it's like a is 1. So on part B, on number 1, we were actually finding the slope of the secant line. Then on part C, since it had that limit h approaches 0, we were finding the slope of the tangent line. So the reason we want to find these different slopes is because the closer we get to a tangent line, the more accurate we are. So when I was just dealing with an average rate of change or slope of the secant line, my slope was -3 between these 2 points. But the slope of a tangent line is the closest thing we have to the slope, and it was -2. So in college algebra, we learned just basic slope and average rate of change. Now we changed it a bit. We put some x's on it. There might be an h in there, and that's still called the average rate of change or the slope, but it's of a secant line that passes through 2 points of your curve. Then if I want to find the slope of the tangent line that only passes through 1 point of the curve, it's the same as the previous example, but you plug in h at the end. Okay, so all of this is to say it all represents slope of some kind of line touching some kind of curve. So, okay. Another word for slope, or synonyms of slope, are slope, rate, average rate of change, instantaneous rate of change, instantaneous velocity, blah, 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 blah. You can read, or f with a little tick mark x, that means f prime, or y with a little tick mark in the air, that means y prime, or dx, that means derivative, or dy dx, that means derivative, or v, that means velocity. So all of these words, if you see any of them or any of these symbols, it means use one of these formulas. Okay. So let's look at how to find the slope of a secant line when given 2 points and an h. And this is a homework problem. And on your homework, it makes you find like 4 different things all at once, but I'm going to take it slow. We're going to find the first thing on this piece of paper and the second thing on this piece of paper. You get what I'm saying? So we're going slow. Okay, so first of all, if they want the slope of a secant line, they're going to give you 2 points, and they're going to look real weird. If you look at this example, it says blah, 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 f of x equals 3x squared. And then it says find the slope of the secant line through the points 2, f of 2, and 2 plus h, comma, f of 2 plus h. Okay. It says they will give you something like this, number, comma, f a number, and they did. And number plus h, comma, f, oh, look, they did. Okay, so if you see something that looks like this, you're going to do this process. Okay, it says the number is your a. Okay, well, what the heck number are we talking about in this problem? Every single time the number is 2. So we're going to say a is our 2, or 2 is our a, whatever. Okay, step 1 says plug that 2 into this equation where the a is. So we're going to have f of 2 plus h minus f of 2 all over h. Okay, and then it looks pretty much just like number 1 from your homework, part B. So now what we're going to do is we're going to find f of a by plugging a into the f of x equation. So let's find just this f of a first, this f parentheses 2. We're going to find it by plugging it into this top equation, just like you did on number 1 in the homework. So let's plug in a 2. We're going to have, instead of 3x squared, we're going to have 3 parentheses 2 squared. And that gives me, let's see, you got to do PEMDAS, as in exponent first, then multiply by 3. Exponent first, so 2 squared is 4, then multiply by 3, 12. Okay, so I have what f of 2 is. Woohoo! Now it says find f of a plus h by doing the same thing. So now we're going to find this left piece of the fraction, f of 2 plus h. And that's what we did on number 1 in the homework. Woo! Okay. So we're going to plug in 2 plus h into this 3x squared. So we're going to have 2, we're going to have 3, because it starts with a 3x squared. Okay, so 3, then no more x, and then something squared. And in place of that x from 3x squared, I'm going to put the 2 plus h. Okay. Then I'm going to do the same thing I did on number 1 on your homework, where we just FOIL out this 2 plus h squared, because 2 plus h squared means 2 plus h times 2 plus h. That's what squared means. So let's see here. F, that's the first things you multiply. 2 times 2 is 4. O, that's the outsides. 2 times h is plusative 2h. In math, we put the number first. I, that's the insides. H times 2, that's plusative 2h. In math, we put the number first. L, h times h. In math, when you multiply 2 letters, the exponent goes up, so h squared. Okay, so we just did this 2 plus h squared. So I'm going to bring down this 3. Then I'm going to bring down what I got from this FOIL, which is 4 plus, let's see, I think these h's, we can go ahead and combine them. 2h plus 2h is plusative 4h. Okay, so I wrote down a 4 from the f. The oi, we went ahead and added it in our head, and it makes 4h. And then the L was h squared. Okay, let's see. We multiply the 3, and then we'll be done with this f of 2 plus h. So 3 times 4, 12, plus 3 times 4h, 12h, plus 3 times h squared, 3h squared. And that's what this f of 2 plus h business was. Okay, step 4 says, take these answers that I just got, 12, and 12 plus 12h, all that, and plug it into our formula. So we're basically doing what we did on part B of number 1, only it has a 2 in it this time. Okay, so it says f of a plus h. Well, what the heck was my a plus h? It was this top left, f of 2 plus h. And for f of 2 plus h, we got this. So let's write this down on top of a really big fraction. And it's going to go in the top left. Okay, now we're going to minus f of a. Well, what was f of a? Let's go find out. F of a was f of 2, and f of 2 was 12. So I'm going to say minus 12, because there's a minus in the formula. Then it's all over h. Okay, now things should cancel out. These 12s at the back end cancel. And we just have 12h plus 3h squared over h. Now step 5 says cancel if you need to. It's okay to have an h in your answer. So I can do that thing where I did what I did on number 1, part B, where I can cancel out an h from all the tops with that h on the bottom. So that h on the bottom can divide into both of these suckers. So the h on the 12 disappears. The h squared on the 3 just becomes a h to the pretend Juan. So we just have 12 plus 3h. And step 5 says it's okay to have an h in your answer. Woohoo! So our final answer is 12 plus 3h. And we did not have to use our graph. Thank goodness.